we about to start because we got a lot to discuss, man. All right, first things first. First things first. We got the tech series today. Tech series. What time is it again? 5 to 6 p.m. So from the last one, I thought it was gonna be more hands-on and technical. That's my bad. So I wouldn't go into these thinking it's gonna be like you need your laptop and you about to be coding some stuff. It's probably more so just yeah, just watching somebody talk and you ask your questions and you just soak up the information. However, after I noticed that, like I did a little viewing with some of the students in 205, and so we came up with the idea to like start crafting an app. So if y'all are interested in crafting apps, like this is outside of class time. Come to 205 on Thursdays, like after 5 o'clock, anytime after 5 o'clock, and y'all can get in groups. Like I can start putting groups together so y'all can actually build stuff. And I'ma just facilitate. Y'all building everything, but I'm facilitating. So, like I said, Thursdays and 205. Tell your friends, tell your classmates. It's already one group that's working on the app, so y'all can start putting more groups together and work on what y'all want to work on. Questions about any of that? What's up?
Are you gonna have this in the lab like we did last time?
Yeah, most likely. Most likely. All right, cool. So today's lecture is going to be on control structures, which is just your if and else statements. We're going to take it a step further today, and then I'm going to show you your logical operators. So remember, we have relational operators, which is your less than, greater than, equal to. Your logical operators are pretty similar, but it helps you do more with conditionals. Questions before we start? Cool. So again, we're going to start with more control structure stuff, which is your else if today. Remember, we learned if, and then we learned else. Else if is a combination of the two. Then we're going to go into the logical operators. And then your homework for this week is going to be a partner-based homework. So I'm going to run the little generator and show y'all who y'all partner with. And yeah, then I'm going to upload the homework. I didn't start it because I didn't want y'all to think it was individual. So yeah, partner assignments coming soon. So else if. When we go into this, think about what if is, think about what else is. Remember, if the if block happens, the else block does not happen. If the if block doesn't happen, the else block has to happen. It's always one or the other, one or the other. So thinking about this diagram we got right here, right? So I think last week we saw a smaller diagram. It was like if the condition is true, it goes to true. If it's false, it goes to some other case. So thinking about cases where we have more than two options, right? It's not just if or else. Let's say we have three cases. Let's say we have some value x. It's an integer. If x is 0, we want to change the value to x. Change the value of x to 1. That's one case. That's if the condition is true. Our second case is if x was actually 1. If x is 1, we want to print out x is 1. In all other cases, so you can think of these as like some if cases, we know the condition for those. And then everything else, we want to print x was neither 0 or 1. So I want you to think in your brain, like how would I start writing this code? And give me a thumbs up when you think you got it. And I'm not going to move on till most of y'all give me a thumbs up. Just conceptualize what the code might look like in terms of if statements and else statements and how we could put this scenario into code. So there can only ever be one else statement.
But it's two ifs.
But you can make two ifs if you want. Anybody agree with that? Two if statements and the else statement? Okay. Cool. So just like y'all said, but I'm gonna start from the top. Let's say I'm writing the code, right? Instead of asking the user for the value for x, do the space, I'm gonna just assign it to be 0. I'm gonna make x equal to 0. I'm gonna say, boom, like y'all said, check if x is 0. That's the first thing I wanna do. If that's true, I'm gonna do something. We don't know what we wanna do yet, but we saw it in the diagram, but I'm gonna show you the code for that after this. This is just the concept so far. So if x is 0, we wanna do something. If x is 1, we wanna do something different. Is this what most of y'all was seeing in your head?
Yeah.
Okay. And then lastly, an else, right? So this is that last chunk that was over here that said any other case you want to do this backup step, right? Is this the code we think will work for this?
Yes.
No.
I'm sorry, I was just saying stuff.
So basically the scenario was if we have some value x, which is up here, we have three main cases. X is 0, x is 1, or x is anything other than 0 or 1. And I'm asking, do we think this code should suffice?
No.
You said no? Why?
Because the if cannot come after another if. You gotta be inside of the else.
No, it could. This if could definitely be after this if. Like you can check, you can have 100 million if statements if you want to. And then you can also have an if inside of an if. There's no like rule to where an if can go. I could also have an if inside of an else. It's all up to like what makes your program do what you want it to do.
Wait, can an else go before an if, or does it have to go if else?
Well, it has to be if else because what would else mean without the if, right?
Oh, okay.
Else is just saying anything other than if.
Okay.
So we think this code will work.
Yes.
And remember, only one of these blocks should ever execute, right? Because if x is 0, we're expecting only this block to get hit, and then everything else we want to be disregarded, right? So what if I gave you this? What do we think will happen in this case? I didn't change anything about the conditions. I still kept the if, and the else. But look what will happen in this case. And give me a thumbs up when you think you got an idea. Yeah, idea? What do we think will happen in this case?
It's gonna print out a second count.
Right. Exactly. In this case, more than one block is going to execute,
Wait, it
but we
wouldn't
only
get-
wanted one.
Wait, it wouldn't get caught up on itself? It would just go straight to it?
Well, not. Going down line by line, right? X is 0.
Mm-hmm.
X is 0 when we start. We get to line 7, X is still 0, right? So this condition is true, which would then turn X into 1. Now, when we get to line 10, we're going to hit this case.
Okay, I thought it was gonna get caught on itself because it's just like x equals to 1, x equals to 1, and then
Nah, so basically what happens in this case, X gets changed. So depending on what goes inside of here, it might mess up everything that comes after. But remember, the idea was we only want one of these to ever be true.
So we need to put C out for that top one or not?
Nah, even if we put C out right here, it still would change the value of, this is what I want the program to do. I want the program to change the value of X to 1. And this is to demonstrate that depending on what we do in here, another one of these blocks of code might get executed. And that's what we do not want. We want only one piece of code to execute. Question.
You know how it said rule is true and false from the 0? You do something like this, and when they input 0, you turn it to x is true.
So you said if they input a 0, you turn it into,
Like if they input 0, it types out x. I mean, this is true.
in terms of what, this example?
Yeah.
So I'm gonna explain it again. Let me know if I'm like tackling your question right. So basically we just saying in this example, we have some value for X and it's gonna be 0. And this is all based on the diagram from the last slide. We had 3 cases. The first case is if x is 0, we want to change the value of x to 1. If x was already 1, we want to print out x is 1. If x is neither 0 or 1, we want to print out x was neither 0 or 1. And so this piece of code is just like explaining and showing that, remember, we only wanted one of those cases to be true. Either x is 0, x is 1, or x is something else. Depending on what we have in this block, because we're trying to convert that idea to code, right? So based on what's in this block, we may have 2 or more cases that end up being true, but we only wanted one to ever be true. Basically, if this is true, we want to disregard everything else. If this was true, we should be disregarding everything else. Only one of these should ever be true. Question?
So my question is, if x is equal to 0 and you're asking me to make x 1, it makes x 1, wouldn't you just go ahead and print x is equal to 1?
Exactly. And that's what we don't want.
So how do you prevent that?
How do we prevent that? About to show you. So this going back over the logical flow, right? We know that x is 0 when we start. So this block is going to be hit. Now that x is 1, when we get to line 10, this statement becomes true. But in reality, once we figured out x was 0, we wanted to just say, yo, I don't want to do anything else. I wanted to stop right there, do everything inside the if statement for the first block that was true, and disregard everything after. That's normally what we want.
Would you just do an inline to stop it?
Well, inline doesn't do much but move the cursor to the next line. Like this doesn't break us out of the if statement. It's not powerful. All it does is move the cursor to the next line. But the concept, you got a question? Oh yeah. Missing my semicolon, man. Dang, you messed up the All right, boom. So let's go back. So now we know x equals 1, x equals to 1 is true as well. So we want to hit line 11. In reality, we only wanted line 8 to be the thing that we're doing in this code block. So how do we fix that? That's the real question. How do we fix that? The way we fix it is with something called else if. And so basically, I know it's a lot of words, but bear with me. So we still have our if, right? If x is 0, we want to do some block of code inside of it. Else, if x is equal to 1, we're going to do some code inside of it. Everything else is just its own case. So by using else if instead of just if, this allows only one of these conditions to happen. Only one of them is going to happen. So there's no possibility 2 of them can happen. It's either case A, case B, or something else.
Okay, so else if essentially, so if it's interfering with like the if statement, you can do an else if and then we'll just stop it right there.
Yeah, so most cases you want to do an else if. Most cases you want to do if, else if, else. Most cases. I don't think I've ever really had a case where I did if. Normally, even if you see that in like real code, somebody will ask you to change the logic so that it's like, it makes more sense. So this is the format we're going to follow for kind of expressing that type of scenario, right? So if anything happens in this if block, everything else gets disregarded. Let's say the first case fails. If the else if case passes, everything after it gets disregarded. And that's important because I could have if and then 10 else if cases, but once one of them becomes true, everything else after it gets disregarded. So this is what we want to follow to basically say only one of these things can be true at a time. Only one of these things can be true. So you will never have a case where an if is true and the else if is true and the else is true. Like, it's just not possible. Because they're meant to represent different cases, right? Questions on this. And I'm going to do more examples, but questions on the concept.
I
Nope, it can be as many as you need to accurately represent the situation at hand.
Oh, okay.
Yep. So how will we fix the code using the else if? I would still have my variable. Let's say I still had that line of code int x equals 0. I would check if x is 0. If so, I can still assign x to be 1. But then next I will have my else if. Still have the same content inside. I forgot my semicolon again. But in this case, once this if statement was hit, once this first if statement was hit and we know that it's true, it will block out everything else. Everything else gets disregarded. So it's only ever going to hit line 8. And once it says, all right, boom, we found our case that's true, we know nothing else can possibly be true after it. So it's going to jump all the way down to after the else. Remember, only one of these cases can be true. It's either the if, the else if, or the else. Only one.
So how did that change?
Hmm?
How did that change? Like, why did it just stop from that? Is it because we added if?
So we added else if.
Yeah.
So when we add else if, remember from the last slide, only one of these can happen. Remember when we only had if, this can be true, but this also could be true. Like that's how C++ is reading. It's thinking you intentionally left out the else because both of these things might be true. So when we know that only one condition can be true at a time, we want to use else if. Want to use else if. And this is typically what your code is going to use in like real life. Most cases at work, I'm using else if. Questions? So when I was making this, I was like, how can I explain when to use else if versus just a whole bunch of if statements? I think that was kind of like a hard question to answer. But I came up with the answer that you normally want to use it when only one outcome can be true at a time. Let's say there are 5 possibilities, but only one can be true at a time. That's when you use your else if. So for example, let's say a student's getting a final grade, right? You know your grade is either going to be an A or a B or a C or something after that. It can't be an A and a B at the same time, right? It has to be one or the other. It has to be one of some set of options. Another case is if a person is a child, teenager, adult, or a senior citizen. You cannot be 2 at the same time. You only one of these can be true at a time. So these are your cases where you will use else if over just a bunch of if statements. Is it making sense? Cool. And lastly, let's say a stoplight is green, yellow, or red. It cannot be 2 at the same time. It can only be 1. So these are kind of like some examples that I thought of to accurately express why else if is necessary. And then again, to reiterate, we know only one block of that code will ever execute. Once one is executed, all the rest are disregarded, thrown out. Anybody need a demo? Cool. Let's do it. Let's see what I got. All right, so the example I have, right? Like I said, for final grades, we know for final grades you can only get 1. You only get 1. You either got an A, a B, C, D. In this case, everything after D is just enough. So I want y'all to help me write the code for this. So it says, create a program that asks a user for their final grade in Comp 1336 and assigns them a letter grade based on that numeric value. And this is the grading breakdown. So to leave that up, I'm going to just start writing my code after. So how do I prompt the user for their final grade? And I want the number grade so I can assign a letter.
Is there gonna be decimals in that number?
Let's say it can be decimals, yeah.
So then double grade.
Or would it be like grade 1 or grade 2? Like,
It won't really matter.
Let's just say we want 1 grade. This is just for Comp 1330. This is like what you see in Canvas the last day of class, and you trying to figure out, all right, what grade did I what letter grade did I finish with, right?
Semicolon. And then pull out. And then the two arrows to the left.
See out. What is your final grading? Final grading
Semicolon.
Semicolon.
Next line.
CN grade.
Why not get line?
Because get like
Yeah.
it
It
can
can
on
only
streams.
All right, bet.
And then grade.
Okay. So now we have, after this, we should have the grade stored, right? So now for the fun part, we want to see how to take this grade. And let's say once we figure out which letter grade they should have, we want to print out, we just want to print out the letter.
Oh, you would make an if statement.
Everybody agree with that?
Yeah.
If,
Grade is less than or equal to, let's just say 90.
What you do? Grade? Oh no.
Greater than.
uh,
Greater than or equal to 90. Well, put your little squiggly arrow.
Yeah, you gotta do that.
And then see out, I guess, A. And then that would be it.
Then it would be the LCL, open,
Is it
grade,
14 you
grade
put parentheses?
is greater.
You gotta put parentheses
for parentheses where?
in front of the squiggle one by the if.
These?
Yeah, in front of it.
Grade is.
Put more parentheses?
Nah, like, yeah,
Go
right
inside.
there, yeah.
What am I supposed to be putting right here?
It's another,
Grade
Oh, you saying inside?
yes.
Oh. Grade.
is greater than or equal to 80.
Oh. All right. So he said.
But the condition is already met on the first if.
Right. So, good. Both of those are great points. So this example probably would be better suited for like the slides that I'm about to do, but those points are really relevant. So if we get here, right, to line 23, we know that the grade was less than a 90. We know it was less than 90. So we are kind of safe to just check if the grade is equal to or above 80, because we know it's not 90, because it would have got captured here. And we know only one of these
I
statements
see,
is on
that's
it.
why the LTIF works.
Yep. But if we would have only had an if,
Statement
then it would have printed every single thing. So y'all following?
Yeah.
Instead of 90, why not put 100? Because then in that case, if it's anything other than that, it'll then just go to the else if, and then it will just do that, right? Or am I wrong?
No, so you would take the lowest number in the grade set and have it greater than or equal to that, so it covers the whole group.
Yeah.
Oh, okay.
Yeah,
That makes sense.
Makes sense.
Can you explain it again?
I mean, it makes sense right now. I don't understand what it is.
Yeah, we about to. Don't worry. So just kind of taking you through the thoughts, right? We already know. Let's say my grade is 89. Say my grade is 89, right? So far, it's gonna go down. It's gonna say, is my grade greater than or equal to 90? For 89, that would be true or false?
False.
False.
So just go.
So it's gonna go down to the else if.
Yep.
Statement, yeah.
And at this point, we know this is true, so it's only gonna do what we put in this block and then terminate. So in here, I can do my C out for B. And so
We can
then,
do the whole layout.
Huh?
All the way through F.
Right, because you want to
Yeah.
cover all the grades.
and so how would I go about adding a case for C? For C.
LCF
Parentheses,
grade
grade.
is greater than or equal to 70.
Mm-hmm.
C out,
C. Yep.
lined up.
And I'm gonna just copy these for D. And so how about F? So we else.
else.
Do I need
Grays.
these? Just squiggly. Why don't I need the parentheses?
At that point, you've already covered 80
It's
to
not a
60,
function.
so anything past that, you will just automatically make an F.
Both. Well, none of these are functions technically. They just the syntax is the same. But for else, Caleb was right. Like there's no else is only used when we know none of these happen, and this is just the default at this point.
Right.
Like we don't have any other handling. We just saying, man, hey, I don't know what to tell you no more. This is what you like. This what you left with. Like that's what else basically means. So at this point we can say F. And so to your point, once I do the next slides, I'm gonna revisit this and show you how we can do like if the grade was between 80 and 89, 70 and 79, because that is technically that's the correct way to do it, but we still are safe to do it this way. So we good? All right, let's see. So give me a number.
69.
Because that's like because that's like an age number. All right, so what should happen if I put in 69? What grade should I get?
You get a D.
A D? We looking good. So that's LSIF in a nutshell. Basically, if you know all the cases and you know only one of them can be true at a time, that's your LSIF.
You show the full code.
I think I made this one public so y'all can. Yeah, I made this public so if you go in workspaces, you'll have access to this. You can run it yourself. I'm gonna start doing that. The ones I do in class, I'm gonna start making them public so you can go see them. And try to learn how to run the code and compile it and run C++ code. At some point, I'm gonna take the run button off. I'm taking the run button off. Y'all gonna have to compile it and run it yourself.
Wait, what?
You think you gonna? Hey, you think you gonna have it have it forever?
Yes!
No, you're not gonna have that forever.
Wait, so real world code and we don't have like a run button or something?
I mean, maybe,
Some do it.
yeah, some. But like in your next class, CS2, he's not using AirStem.
You know him?
Kinda.
Who is he?
I don't know him like that, but I highly doubt it's gonna be this simple. And you don't want to just deprive yourself of the learning, the learning experience, man. It's college. It's
You guys think about
all right, so we feel good with LSIF for now. All right, bet. So moving along, and this is just the disclaimer again. And this is a way of thinking about like converting your code that you already have that works perfectly fine to an else if. Let's say I have an else block and then I have an if inside of it. Technically that will work, but normally you want to convert that to an else if. I don't have a like real case. Actually, I think I do have a case, so let me show you. So let's say, remember we did the rental stuff, right? We say if the user is over 21, they can rent any normal car, but if they're specifically over 25 as well, they can rent luxury. So I'm gonna show you. The first case is if the user is less than 21. If they're less than 21, we know they can't rent any vehicle. If they are over 21, we know there's two cases. Either they're between 21 and 25 or they're over 25. They're either between 21 and 25 or they're over 25. So one way we could write this is if age is greater than or equal to 21, and I'm gonna teach this in a second, and the age is less than 25. Oh, I didn't even mean to put that parentheses right there. So, and showing you, walking you through what I just wrote, right? So I'm saying from 12 to 14, this is me seeing if the user is under 21. If they're under 21, they can't rent anything. Else, they are over 21. We know there's two cases, either they're between 21 and 25, or they're over 25. So I handled the first case, which is between 21 and 25. And I'm gonna teach this and thing in literally like the next slide. But just believe me when I say this case will cover if they're between 21 and 25. But remember, we have one final case, which is that they're over 25. How would I add on to this to check or to handle that case? We could do an else if, but we know there's only one final case. So it could just be else. Else. But let's say there were like more groups, right? Let's say there were more groups, then we would have our else if for each of those groups. But since there's only one final group and that's 25 and over, we would say you can rent luxury. And so even if you just kind of follow along with your eyes, right, you see else if. Else if. The else block gets hit and then the if gets hit. This is perfect. Huh? This is kind of like how you would have done it last week before I taught else if. And this is perfectly fine. I don't mind this necessarily, but like, let's say you tried to send this code out for review at your internship, they probably would say, can you refactor this into an else if?
So else if basically is the easier kind of way, or more acceptable way to job.
This?
No,
Or
else
else if? Yeah, else if. When you see it, like, it'll be if, else if, else if, else if, else. It's like, I think it just registers better in the brain, like, these cases. Versus this, you gotta kind of walk through a maze to figure out what's really going on, what case is gonna get hit. Once you start nesting stuff inside of stuff, people don't even really want to read it to figure out where it's going.
So both of them statements got to be true in the second if statement for that statement to print out?
Yes.
Oh.
Yes. So following it from the top, right? We know that the else has to be true, and then one of these has to be true as well. So both of these statements are based on the else being true. Again, both of these statements only ever get visited if the else was true in the first place. Because let's say the user was under 21. Now this would have got disregarded anyway. There's no need to check if they're between 21 and 25 if we already know they're under 21, right? So it's like, there's no point in doing those extra checks if we've already found our condition that was true prior to that. So in this case, and I'm gonna run this and see what happens. So somebody give me an age. What's an age? 18. What should happen if I put in 18?
You can't
Sorry, you can't read.
And should any of this stuff print as well, or just? All right. Boom. What if the user is? What if they're 23?
You can only rent normal cars.
Everybody agree with that? Only normal cars? Only normal cars. And this is still using the same logic as else if, because we know only one of these can be true at a time. You're either under 21, you're between 21 and 25, or you're over 25. You can't be in more than one of those groups at a time. Make sense? Cool. So now for logical operators. So we have three main logical operators. The one I was kind of using in one of those demos was the AND operator. This is when I have two conditions that I need to be satisfied at the same time. And this only evaluates to true if both conditions are true. So I can't have one condition evaluate to true and one end up being false, and then we still proceed. Like, both of them have to be true. Like us doing the steps inside of this, what we're gonna see in a second, both conditions have to be true. Next is OR. this is mean at least one condition is true. At least if one condition is true, we can proceed. And then lastly is not. We saw this a little bit with the not equals to, but this symbol just means not. And so this will just flip a condition over. So if a condition is already true and I throw the not in front of it, the condition becomes false. Likewise, if a condition is false, but I throw this exclamation mark in front of it, the condition now becomes true. And I'm going to show an example of all of these, but these are the operators.
Wait, can you go back?
Yeah, my bad. So remember I said for and, both conditions have to be true in order for the condition, the broader condition to evaluate to true. So help me fill this out. For the first one, let's say I have a true and a true. What should this evaluate to? I ain't hear enough answers. Remember, and I need both conditions to be true. So if I have true and a true, that means what? True. If I have true and false? False. False and true? False and false, we know it's obviously, somebody said true. Nah, so with the and operator, you only ever gonna have true if you have two true statements. Just like, let's say I'm trying to drive, right? I know I can only drive if I have a license and insurance. If one of those things is missing, I cannot drive legally. Showing more examples. So you still want to have your same setup for if and else, right? And this is going to be like a kind of basic example. This is the template code we always going to have for if else. Remember, you have your first condition, and then you're going to throw the two and symbols in your second condition. So don't get confused by the fact that there's a symbol in between the conditions. This will still be the same exact conditions we've been dealing with, right? So let's say I have one condition that 3 is greater than 2. We know that to be what? True. We know 3 is greater than 2. But we still have to check this other condition to see if we can print out yes. Because all of these conditions have to be true. Let's say the second condition is that 2 is greater than 5. We know that to be what? False. So what will happen in this case? We'll print out no. Anybody curious why we print out no instead of yes?
Because the false outweigh the true,
Yep.
and you'll print out the no because the answer is
Exactly.
false.
Yep. If there's, let's say I had 100 conditions and the 100th one was false, we throwing it all away. We can't do nothing with it.
So how many ands can you put in one?
As many as you want. As many as you. Sometimes in my job, bro, it'll be like 7. Like we only want to do something specific if all of these conditions are true.
Wait, is this all gonna be in the assignment you put?
Always.
You can so since one of those isn't true, does that like negate
The whole thing
everything
gets
after that?
negated. Yep. The whole thing gets negated. If at least one of these is false, the whole thing gets negated. So remember, this is like a case where we know we need all of these things to be true in order for us to proceed. Like I said, with the driving example, you need to have your license and registration and your insurance. Like you need to have all of this stuff in order to drive. Technically. So let's say I want to check if a user is a teenager, right? And let's say I'm gonna store their age and a variable. Let's say I'm not gonna give it a value yet. How do I know if somebody's a teenager? Well, yeah, you can ask them, but like,
If they at least 13.
okay, so age, and I have something at 13. What's the other? So they're over 13, Where does being a teenager stop?
18.
18? What about 19? It's not. I mean, let's say not in terms of the law, but in terms of just numerically, what's the last teen? Yeah. Now you good. All right, so boom, we know age something 13 and age something 19. The age needs to be between these numbers, right? It can be these numbers or it can be between. So age needs to be what compared to 13? Greater than or equal to 13. And how about 19? Less than or equal to. And you see how both of these conditions need to be true in order for them to be a teenager. Both of them need to be true in order for them to be a teenager. So what sign will we throw in the middle to say both need to be true? And so all we would do to finish that off, throw it inside of an if. We could print whatever we want or do whatever we want. And you said else? What would we do in the else case? You are not a... Yeah, it could have been a child or it could have been somebody older than 19.
Else if statements.
You could.
If they're over, if their age is greater than, you're doing anything less than.
Yep. So if you wanted to know exactly why they weren't a teenager, you could add your else ifs to see were you younger or were you too old. So this is like one use case to see how to use an else if, right? Like we know both of those conditions need to be, well, not an else if, but using the and operator. We know both of these conditions need to be true together in order for them to be a teenager. And so some of the examples I gave earlier, one is to drive, right? You know you need your license and insurance. Also, let's say sports betting. You got your 20-leg parlay. You know all of them. Your 28-leg parlay, all of them got to hit. All of them have to hit. You miss one, the Lions don't score, hey, you can throw that ticket in the trash.
You be throwing parlays?
Nah, I don't gamble. I don't gamble. So these are like some practical examples of when to use the AND operator. You know, all of these conditions need to be true in order for some expected outcome to happen. Make sense? Cool. So let's say we got or. Remember, or is when either one or at least one condition is true and we good. So let's say we have true or true. True. True or false? True. False or true? True. This last one? False. Again, to reiterate, as long as one of these conditions, and just like we can have 100 ands, we can have 100 ors. As long as one is true, we're good. We only need to satisfy one of these conditions and we're good to go. Likewise, we'll still have our same if structure with the if and the else. We'll throw the two conditions on both sides of the double, like straight line symbol. Same as we would do with and on the same thing for. So in this case, right, is 2 greater than 2? Nope. But is 2 greater than or equal to 2? Yes. So in this case, we can print out yes. So in this case, the computer can't just say, I found one false, so let's throw the whole thing away. It has to read all the given conditions to see if at least one of them is true. It has to look at everything. However, if it did come across a true, let's say the first condition was true, it doesn't need to look at anything else necessarily, because all we needed was one condition to be satisfied and we're good. Does that make sense? Question. How is 2 greater than or equal to 2? Remember, this is really asking you two questions. it's asking you is 2 greater than 2 or is 2 equal to 2. And we know 2 is equal to 2. Other questions?
Why don't you just put it's 2 greater than equal to 2?
Hmm?
Why don't you just put it's 2 greater than equal to 2?
I mean, yeah, for the example that, but this was just to show you. I really tried to trip you up and like make you think both of these are asking the same thing. But I just threw the equal sign to say like it looks the same at first glance if you don't really read it, but the equal sign is a deal breaker in this case. Other questions? Cool. So maybe take 60 seconds and think of some scenarios where 2 outcomes could both be true based on the conditions. So I think I had an example. So yeah, my example is, let's say you're an underclassman. We know as an underclassman, you could either be a freshman or a sophomore. Think of some cases like that. Just turn and share. We're gonna see who got the best outcome. I should have known. I got any willing participants? Somebody want to volunteer? What's up?
If you're considered deaf or blind, you're legally.
Yes. So what is that called? This is. I don't. All right, bet. So if you're disabled, you could be deaf, or it already was. That. So yeah, you could be deaf or. Oh, my bad, blind. Whew. My bad, man. Bro, don't be laughing at me. Yeah, you could be blind or hard of hearing, and that means you are disabled. You got another one? Full-time student. So as a student, you could be. Yeah, honestly, you could be a kindergarten student. You could be any, you know what I'm saying, as long as you. I mean, I get what you're putting down. Any other ones?
You got a phone. Either you got an iPhone or an Android.
Okay, boom. So as a phone holder, you can either be an Android. What's wrong with Androids, though? I'm the Google man. I got to vouch you. You know what I'm saying? What's up?
If you have like a job, it could be like a white collar job.
Okay. So if I'm employed, I can have white. I think I spelled that right. Do you know 3? You don't want to stop, right? You don't what's up?
I already know what he's gonna say.
My man said if you about that drinking life, you can either do your white or your dark. Dark?
You drink water.
Nah.
You like dark?
Nah.
I'm about to say, you're nasty.
I was just trying to get some of y'all to tell them y'all, so I don't drink that. Alright. Alright, is it clicking? It makes sense why we would use or, right? Because any of these pairs could be true to make the overall condition true, right? And then y'all need a picture of this or? Huh? Me? I got iPhone and the Android. My Android for work though. Nah, it's in the
Sound like
Alright, so this last example and then yeah, so let's I think we got it. I'm gonna skip over this just because we kinda running low on time. So this example was just showing you like, let's say we wanted to figure out if a person qualified for a discount. They can either be less than 10 years old and qualify for the child discount, or they can be over 65 and qualify for the senior discount. Let's say the discount is the same price, but based on if either one of these conditions is true, we will give them the discount.
Well, wait, what if you were in between class?
Then you don't get the discount. Right, you have to be a child or a senior.
Yeah.
You're gonna be 6 for about 6 years.
Huh?
You're gonna be 6 for about 6 years.
No,
Because like, I know had your mom or grandma or something tell you you're gonna be 10 today, and you're actually like 11 or 12.
Yeah, they probably just did it. They didn't even tell me. I was just like, all right. All right, so bro, actually let me. All right, this is the last operator, and then I'm gonna go back to the last slide. And so remember, not just inverts a condition. So this, we know this condition 3 greater than 2 to be what? True. We know this to be true. If I throw the not symbol in front of it, it's now false. So any condition that was previously true, if I throw this exclamation mark in front of it, it just flips it. It flips the result of this expression. That's all it does. And so given, don't cheat, given this chart, right, help me through it. So I got 2 conditions and I'm throwing my logical operator in the middle, and be aware of this one that's using not. But going down the list, let's say I got 3 is greater than or equal to 3. We know that to be what? True. And 2 is greater than or equal to 2? True. 5 is less than 10? True. 2 is less than 2? False. So this becomes false. This is false because remember, both of these have to be true in order to evaluate at the end to true. So 5 is less than 4? False. And ABC equal to ABC? True. Remember, we have or. So as long as one of these conditions is true, the overall condition is true. So for this next one, I have, and normally how I look at it is I do what's on the inside first, then I just reverse it. Yep. So I do 2 plus 5 is what? Math guy. 2 is So this is 7. Is 7 equal to 4? No, but if I put the not in front, it becomes what? True. And then I have an and I'm saying 2 modulus 2 is equal to 0. We know that to be true. So the output of this should be what? True. Questions on that one? I threw a whole bunch of tricks in there to make sure y'all got. So
modulus means remainder, right?
Yep. So if I divided 2 by 2, I would get 1 with a remainder of 0.
Oh, okay.
Yep. So I'm just checking.
You use
He just said it.
I'm talking about the 4th one. I was trying, what does that mean? I thought it was like, how was
This?
2 divided by 2 equal to 0, but I saw you.
Oh yeah, this is, well not, it's
Module.
percentage. We good on?
You looked at me like that, bro.
We good on?
Bro, look at me. He was waiting for me to say something. You instigated.
We good on this one?
Yeah.
sure we good on number 4?
Yeah.
Y'all good on number 4?
Because 2 divided by 2.
Alright.
Oh, hold on.
Just to re-explain it though, when I see stuff like this,
Oh, you talking about 7.
when I look at stuff like this, I do what's inside the parentheses first. So I would do 2 plus 5, I know that's 7. Is 7 equal to 4? I know it's not. Then I would look at this symbol to flip it. So normally I know that conditions to be false, but since I'm using the not operator, I flip that, so now it's true. And then this one is just dividing and taking the remainder. So I'm doing 2 divided by 2, which is 1, with a remainder of 0. So this condition is true as well. So the output is true. For this last one, what we got? 4 plus 6 is equal to 9. We know that's what? False. And then we got 2 greater than or equal to 0. That's what?
True.
That's true. So the output should be what?
True.
Anybody want to explain why it's true?
Cause you pick, what's it called? It's like either or.
Right.
So one of them is true.
Yeah.
So that makes that whole like.
The whole thing is
The
true.
whole thing is true.
Yep. So your operator really matters. Your operator is like the most important thing because that determines if you can just take one condition and let that be the spokesperson for all the conditions, or if all of them need to be true at the same time. So like you said, the last one would be true. And we went through this. And so let's say I had false and I negate it. What would that be? True. And this last one? False. Whenever I throw the not in front of something, so let's say I had a bool variable, right? It has a value of true. If I use that variable name and put the not in front of it, it flips the value of that variable. That's normally how it gets used in industry. So normally in my job, I'll have some bool variable in the beginning of my code. It has a certain value at the time, and I want to say, what would happen if I invert the value? And so I would just throw this exclamation mark in front of it. What's up?
Are these operators present in different coding languages?
Yep, every language. Yep. So now we're making good time. And like I said, your homework is going to be partner homework. Say, oh no. So your homework is going to be partner homework. I'm about to load up the generator. Don't pay attention to the groups that's on here right now. I'm gonna spin it up, man. Y'all ready? I'm gonna do it 3 times.
That's what I'm trying to figure out.
What you mean? Who is? Oh.
Hey, he on your head, boy. He trying to subliminal jokes on you. Me personally,
All right, I'm gonna click the button 3 times. So this is go number 1. Go number 2. Nah, I think this was 3. Nah, it flips twice for each one. All right, so these the whoops.
do your homework.
I put Eric. Oh, this my man Eric right here.
That's true, man. I'm sorry, what?
I thought that's his real name.
Arrow.
Arrow. Did I put Eric for somebody's name?
You want her?
No, it said Derek. She said Derek.
Oh. All right, so these y'all groups. I'm about to upload the work to EdStem.
Who doesn't?
And I'm gonna upload this to EdStem as well in case your group member is not. It still say Pepper? So I'm gonna upload this to EdStem in case y'all member's not here. But as for the actual assignment, so for this assignment, I'm gonna walk y'all through it after I upload it. All right, so you should be able to go in there and see it. I'm gonna go off my.
Not with it.
What, for the homework?
No, for the midterm.
Oh. Oh, you seen the general? Yeah.
That nigga ugly, boy.
All right, so look, this is the last one. So your assignment is gonna be to build rock, paper, and scissors. Y'all gonna build rock, paper, and scissors. However, you're not just gonna code it up and get the check mark on instant. That's not how this is gonna work. You're gonna have to do actual check-ins with your TAs and myself at each step. And so you're gonna have a spec, and this is gonna walk you through what I'm expecting for the assignment. It's like a user playing against an opponent, and based on the result from the game, one person gets like their rank boosted according to this rating system, and the loser gets their rank adjusted based on the loss. And so all the rules for that are included in the project spec, so you should be able to see it now in ASTEM.
Can you put this on our resume?
I doubt it. This is like,
Basic.
yeah. But so going through each of the little slides that we have here, right? So the first thing you want to do is it's asking you to create a chart either on paper or on your computer, and I want you to create the following columns. So user rating, opponent rating, user move. And so this is simulating a game of rock, paper, and scissors, and I want to make sure that you understand what the data type for each of these should be and how to actually calculate the user rating. So before you go into any code and get confused and start, because once you start writing like inefficient code, it gets hard to debug it and figure out where your problem is at. So first I want y'all to think about the concept. Make sure you understand the concepts, and then check in with myself or TA for approval. Then you'll move on to actually writing the code. You're gonna write some code. Then there's another question asking you to implement more of the project. You're gonna answer these questions and get approval again. After that, you can write the full-blown rock, paper, scissors game, and it's basically guiding you through the steps. So by the time you get here, you should be pretty firm on what I'm asking you for. And you always have the doc that I was looking at to kind of guide you through, you know, each of the steps, an overview of the problem, what I'm really expecting from you. And so you're gonna work with your partner and make sure either one of y'all can get approval from me. But once you do get it, you're gonna mark true or false. Well, it's due on the same schedule as all the other homework. So I mean, y'all can work on it now. If somebody want to get some steps out the way and get approval while I'm here, you're free to do so. I try to leave y'all more time than this, but yeah, you're free to start working on it now. And let me know if you have questions. And I put a video of like if-else statements. This is a really good video if you need to kind of refresh your memory on if, else if, or else statements. Any questions on the homework? And I'm gonna put the groups back up there so y'all can get that going. Nobody want to work on it now?
We should like raise our hands to know who our partners is.
Hmm?
We should like raise our hands to know who our partners is.
You don't know who your partner is?
Like a person is like themselves. I really don't know them.
I mean, you don't know your classmates? Like,
Do I look back there with your
hey, bro.